Good afternoon, ladies and gentlemen. Welcome to Math 20-3, Chapter 4 Review. So, first things first, what is scale? Well, scale is a ratio. Usually it's smaller, a little bigger, a model, or actual. It's what we multiply by. Now, what's the difference between scale ratio and scale factor? Well, scale ratio, say the model I'm making is 1 to 48. This is one model foot. Equals 48 feet on real object. Now, scale factor is that ratio written as a fraction. 148, and remember that is model. Okay. Now, sorry, I apologize, I'm having a smidge fast. And if I'm going to make it fast, you can pause the recording and watch it again. Now, there's 3 different types of drawings we studied during this unit. Give a brief description of each type of drawing. Well, the first is orthographic. And we have orthographic. It was isometric. Isometric was perspective. Now, orthographic, and this is the front, side, and top. So the front would look like that, and then would be a handle box. Okay, and the side would be that, and the top could be. You have to figure out how that goes together, just to be very confusing. So let's grab the example. Isometric is when you've got that dot paper. Now the advantage of isometric is that it lets you do a crude 3-dimensional drawing. That's the right graph paper, that's dot paper, which gives the idea what I'm aiming for here. Anyway, something like that. Now, perspective, or 1 point, you have your front of your object, you have your horizontal, you have your vanishing point, and then you drop that like that, and then you erase bits you don't need. Apologize. There we go. There's our 1 point perspective drawing. So there we go. That's the 3 different types of drawings. All right. So what's the difference between a component drawing and an exploded drawing? Well, a component shows the base. But exploded drawing shows the bits and how they fit together. Now, we really didn't talk about components, but we did talk about exploded drawings, the bits and how they fit together. Now, what type of drawing would you use to create an instruction manual to assemble a chair? If you get furniture, you use exploded drawing. It shows you what goes where and makes life easier. All right? Now, model airplanes made of a scale of 1 to 128. What's the scale factor? Oh, so you just factor the factor. You rewrite your ratio as a factor of 128. Now, if the airplane model has a wingspan of 30 centimeters, what's the wingspan of the actual airplane? Remember, this is 1 to 128. That's model. Real. That equals the model's 30 centimeters for x. So here we have to do the cross multiply. 1 times x equals 30 times 128. Come on. Wakey. What's your issue? Three, 4, 0 centimeters. Now, that's centimeters. It's kind of an ugly number. How many meters in a centimeter? It's 100 centimeters. So if you divide the times this by 1, divide by 100, you get 38.4 meters. So the actual airplane is 38.4 meters across. All right? So, next question. The distance between two cities on a map is 7 centimeters. The actual distance between the two cities is 350 kilometers. What's the scale used on this map? Well, the scale, 7 centimeters, 350 kilometers. Now, that I'm happy with that, but can you divide 250 by 7? Yes, you can. That is 1 centimeter, 50 kilometers. That's a better number. The 7 and 350 are fine. Now, what is the scale used on this map? 1 to 50. And notice I said, write your answer in the most simplified form. So 7 and 350 is good, but I expect you to figure it out. Moving on. In a photograph, a man is 1.3 centimeters tall and the flagpole is 4.8 centimeters. If the man is 190 centimeters in real life, how tall is the flagpole nearest centimeter? Now this one's sneaky because it's not model versus real. It's one versus the other. So I was going to say photo versus real. Probably a better way. So in the photo, the man is 1.3 centimeters tall. And in real life, he's 190 centimeters. The flagpole is 4.8 centimeters in the picture. For x. Now, why don't we take these centimeters divided by centimeters, cancels out, or whatever. Here, the important thing is the cross multiply. X times 1.3, 1.3x equals 4.8 times 190. And I can't do that in my head. So, 4.8 times 912. So, 1.3x equals 912 centimeters. So, how do I get rid of times 1.3? Yes, divide both sides by 1.3. 912 divided by 1.3, 701. Divide by 100. Actually, double check. Is that divided by 100 to get meters? Yes, 7.01. or 7.0 meters. Okay. So that's how the flagpole is. Now I'm going to stop here. You guys have any questions, review this, otherwise we're going to go on to the next set of questions.